This video is a short introduction to Project Noor in advance of the demonstration scheduled for the beginning of June at USCENTCOM headquarters in Tampa. Over the last year, the Strategic Multilayer Assessment Office, or SMA for short, has sponsored a Reach Back Cell effort in support of USCENTCOM. This team effort has conducted research and developed extensive written documentation from SMA's global network of over 150 subject matter expert contributors in response to 40 questions submitted by USCENTCOM. The result of this effort has been the production of a robust corpus of nearly 1,000 pages of information addressing issues and providing understanding of the goals and motivations of each of the key actors involved in the Iraq and Syria conflicts, regional stability, and the emergence of a virtual caliphate or virtual jihad. Because there's so much detailed information in the corpus, and because the average staff officer would be seriously challenged to derive the full measure of benefit from this research, and because this material might be used for other purposes or by analysts other than those who asked the original questions, the SMA team has taken on a short duration effort called Project Noor. We thought this name would be fitting given the region. Noor means light in Arabic, and the objective of Project Noor is to shed a light on the analyses, forecasts, and recommendations contained in the Reachback corpus in order to help people see these insights and look into the future. Project Noor. What is it? Project Noor is a short-duration, proof-of-concept effort that pulls together a diverse team of social scientists, data scientists, computational modelers, and visualization experts to provide a set of tools intended to make it easier for members of the USCENTCOM staff to find what they need in this treasure trove of information. Please note that this is indeed a proof of concept. It's kind of ugly and it's not particularly slick, but we want to provide this capability quickly before the information in the corpus is past its use-by date. So now that the expectations for this demonstration are refocused to an appropriate level, let me introduce you to the cool things that Project Noor does contain. The Project Noor technical architecture is composed of content extraction tools and visualization tools, as well as predictive modeling components that can together be used to develop an improved understanding of the future conditions of the region. First, let's look at Project Noor's content extraction tools. As part of its content extraction and text exploitation component, Project Noor tests out two text search and discovery approaches. The first approach is an AFRL program called the Advanced Text Exploitation Assistant, or ATEA for short. ATEA enables analysts to extract entities from large volumes of unstructured text, like the Reachback corpus, to perform link discovery and analysis among these entities. The ATEA system currently provides an automated document handling and processing pipeline that identifies various types of intelligence reports, extracts metadata about the report, performs entity, event, and relation extraction on the body of the text, and consolidates entity information across the many documents that entity was found in. The system provides semantic pattern search capabilities, enabling a user to go beyond simple keyword search by specifying the semantic types of information that they are looking for. The ATEA user interface provides a number of tools that can validate, review, and correct the automated extraction results, that can mark up additional information contained in the process reports, and that can save investigation folders and export results for use in downstream systems. ATEA's automated processing pipeline, user review, and data export tools have produced a rich set of entities, events, and relations from the SMA Reach Back corpus, providing input for the downstream visualization and analysis tools of Project Noor. The second content extraction approach is NSI's Thematic Coding effort. USCENTCOM operators, planners, and analysts face a major challenge when trying to ingest the reams of knowledge generated by the Reachback effort. A survey in 2016 found that end users felt the response is both too long to fully absorb and the executive summaries too short to reveal new, surprising, or highly relevant nuggets of information. Given this, NSI developed a knowledge index to catalog major findings and insights searchable by substantive theme as posited by experts over the course of the Reachback effort. Here's how it works. NSI creates a detailed outline of information within the corpus related to a particular nation-state's interests, leadership characteristics, disposition of its population, future forecasts, recommendations, relations with other actors, and stability factors. For non-state actors, we also categorize information relating to the group's appeal and source of strength. This results in a hierarchical outline of key points that can be quickly perused to find novel, surprising, and challenging information. The index is linked to both the paragraph and the document, so sourcing is maintained. Let's move on to Project Noor's visualization tools. Project Noor includes two types of data visualization. The first data visualization approach is GSI's Human Atlas. GSI will link the SMA data to its own verified data content in order to operationalize the content as actors and places. Planners and commanders can immediately visualize the terrain, actors, and themes of the SMA content in order to develop a course of action. This is a similar process to how GSI analysts helped answer reachback questions. More specifically, coded entities from previous steps are related to places, groups, and people in Syria and Iraq, so that, for example, Sunnis in Iraq or the Kurdish in Syria can be visualized as networks of family groups, clans, or tribes across a geography. Entities are connected to GSI's research-based human geography data, which consists of data for things like sociocultural groups and relationships, prominent individuals, levels of influence for groups and individuals, ethnicity, religion, language, political allegiance, and temporal change. For modeling, a planner can navigate conditions described by SMA experts, filter, sort, and rate SMA content, and use that content to drive what-if scenario modeling. Project Noor users will be able to see how localized and context-specific factors will develop around particular events. The second data visualization approach is Argonne's immersive 3D visualization. How can we discover the answers to highly complex geopolitical questions in mounds of text or through flattened representations? Can we prevent overloading analysts with data by allowing for more intimate data exploration that unfolds information as the user moves through and asks for more detail? What if we could move from only flat map 2D reading to freeform complexity exploration? Argonne National Laboratory was asked to provide an immersive 3D visualization for the Project Noor corpus and models. The goal is to provide USCENTCOM analysts with a way to virtually explore and more deeply understand the nature of the complex system properties, structures, and emergent behaviors. Other complex problem domains where Argonne has applied its immersive 3D visualization tools include transnational organized crime, criminal justice system overload, and large-scale food insecurity. For Project Noor, Argonne has developed a 3D immersive visualization that provides for exploration of SMA data manually coded by NSI, SMA data machine coded by Athena, and Athena Simulation data. The Project Noor 3D immersive visualization shows promise for exploring and explaining complex patterns, and for providing the ability to step inside the data for further exploration of system properties. Now let's look at Project Noor's modeling components. The ultimate utility of the Project Noor suite of tools is to provide a capability that will enable a commander and staff to better understand the population dynamics influencing behavior across the operational area of interest. To accomplish this goal, computational modeling tools were integrated into the Project Noor architecture to enable, for example, a J5 planning staff or a J35 future operations cell to ask pointed what-if questions in support of their course of action development and analysis processes. For the purpose of this proof of concept, two computational modeling capabilities have been used to generate a select set of planning insights that might inform a staff about the intended and unintended consequences of their engagement options. These systems are the Senturion Model and the Athena Simulation. A team from USCENTCOM has used a Senturion agent-based model to study the corpus data and provide understanding of the most probable impacts of U.S. actions in Syria. Senturion models various stakeholders on their position, influence, and saliency. The model uses game theory, median voter theory, and utility theory to understand and visualize the negotiations between each stakeholder and the most probable outcome. The analysis of the model will identify stakeholders with unused leverage, coalitions, and trade-offs. This use case will assist USCENTCOM in understanding what actions change adversary and allied stakeholder behaviors to achieve U.S. strategic objectives. TRADOC G2's Athena Simulation has also been integrated into the Project Noor architecture to provide predictive analytics based on the results developed by Athena and synthesized by the Human Atlas team. These data elements, derived from the USCENTCOM corpus, were coupled with actor sentiment analyses conducted by Senturion and selectively converted into Athena simulation inputs in order to establish an Athena database capable of running multiple use cases reflecting the effects of operations on the region over time. The intent is to show the implications of employing both effective PMISI-oriented engagement options and cognitive maneuver. Athena is a socio-cultural modeling capability designed to provide commanders and staffs an improved understanding of the second and third order effects of their engagement options on regional stability. The simulation models things like force activities, economic engagements, and information operations to understand how those effects intersect and interact across the PMISI variables and ripple through local populations. Ultimately, in support of Project Noor, Athena outputs will provide insights and forecasting analysis for assessing changes to population attitudes, regional stability, shifts in control and influence, and changes to relationships between key regional actors over a period of 3 months to 3 years. The SMA Reach Back Cell has produced a vast corpus of knowledge and insight in support of key USCENTCOM questions regarding Syria and Iraq. On its own, this 1,000+ page collection of documents is a valuable resource, but due to its sheer size and density, it might prove less helpful to a busy planning staff. Therefore, Project Noor seeks to provide USCENTCOM with a quick and easy way to search through and make effective use of this vast treasure trove of information.